JITs are great for browsers, but ahead of time is great for, say, server side, because, like, for example, there's no startup time, there's no cold start. You just have a binary already. There's no, I've got to start the entire runtime and warm up the JIT to be fast or anything.
Hello, welcome to devtools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Jess.
Hey everyone. Today, we're really excited to have Oliver Medhurst on. Oliver, did I say that correctly? Just want to make sure. Great. So Oliver, you are the creator of Porffor, which is and hopefully I also said that right, a JavaScript like ahead of time compiler, which blows my mind. I'm like really excited to dig into like how I didn't even think this was possible. So it'll be interesting to just learn more of the technical details. But before we start talking about that, we'd love to just learn a little bit more about you. So would you like to tell our audience a little bit more about yourself?
Yeah, I guess I have a very untypical developer background where I was just doing it in my free time since I was like, I think 11. And then my first full-time job was I joined Mozilla working on Firefox stuff when I was 18. And then I quit that just over a year ago now to do this full-time. This is very much like most of my adult life is this project, for better or for worse.
So you started at 11. Were you like already got hired by Mozilla at 18? Were you already like in browser internals by that point?
No, so like the way I got into browsers and more, because I was doing web dev, like most of my like actual development stuff. Like I did some part-time like contracting things, so I just thought it was fun. And how I actually got into it was just, I think I found a bug while working on some open source thing like me and one other person was using. And then the person triaging was like, oh, you can fix this, it's 5 lines. And I was like, oh, I don't know. Then I did it and I just got addicted to fixing more and more bugs.
That's cool. Were you working on like the JavaScript engine? What part of the browser were you working on?
Yeah, so when I was doing bugs, I was just doing basically wherever I thought was interesting. Like I think I did a lot of remote debugging stuff, then some CSS stuff, and then I settled into the DOM, which is just like the JavaScript engine and the browser talking to each other. So like basically every API exposed in every API exposed in a web page is basically DOM, like everything of documents, elements, CSS, and that's what I got hired to work on. So I settled there.
Yeah, so for the project we're talking about, Porffor, how did you get into that? Like, looking at your website, it looks like your previous project was you trying to create a browser with just JavaScript. And I feel like I can connect 1 to 2 where you're like, oh, I'm making this thing. Oh, I want it to be fast. And then you went down the engine pipeline.
But yeah, I started that mostly as a joke. I think I was joking to someone in person of, oh, no one's made a browser engine in JavaScript. And everyone, it's like it will never be actually like anything you use, but it's just fun. I think I got like pretty basic web pages working, but it's only, I want to say, like 5,000 lines of JS, which is pretty understandable. And that's not like anything fancy. Like the entire, like for example, like parsing HTML is very well specified. You just read a long document, pretty easy to translate into JS. So yeah, from there I was like, oh, it'd be really cool if I added a JavaScript engine too. But I kind of thought interpreters were boring. Even though like I've never actually written an interpreter, but like I've seen them done. Like I think I made a toy language once, which used one a while ago, and I was just like, oh, ahead of time is really cool. Everyone says it's impossible for JavaScript. I might as well waste my free time on something people say is impossible. So it's something innovative, something interesting. I just got sucked into doing that in my free time.
Maybe to really like lay the groundwork for our listeners and people who might not be like fully like steeped in compiler terms. Can you kind of explain how like JavaScript normally compiles like with just-in-time compilation and then like how what you're doing is different?
Yeah, so typically today, basically everything is just-in-time compiled or interpreted. Browser JS engines will have, I think like V8 has 3 just-in-time compilers now and interpreter, because like you can have a really fast JIT compiler, which will make your code like machine code level fast, and that also might take a second to compile like React because it's such a big JS file, for example. And so it would suck if every website had a 5-second delay loading just compiling. So yeah, ahead of time is basically you do just in time, but you don't do it just in time. It's my like best explanation. Where on the developer's machine, like a bundler or a DevTools, you just take that JavaScript, make it into WebAssembly or like a native binary, like anything in between.
So that's all and good, but like I've never used a ahead of time compiler. What are like some of the benefits versus the just in time compiler?
Yeah, essentially, because most JS engines are built for browsers, they're very browser orientated, which is great. And like mostly translates well to server side stuff or say embedded things. Like there are a bunch of JS engines made just for embedded devices because you have, say, half a meg of RAM instead of gigs, which you would have for a browser to use. So every JS engine people use today is like 99% V8 or like maybe JavaScript core if you're using Bun or Safari. So it's just, yeah, basically jets are great for browsers, but ahead of time is great for, say, server side because, like, for example, there's no startup time, there's no cold start. You just have a binary already. There's no, I've got to start the entire runtime and warm up the JIT to be fast or anything. I did a benchmark where I got AWS Lambda running with the like managed node, which is really fast because it's cached well. I think like specifically optimized for it. And I have Porffor just running like a hello world HTTP thing. And I think my cold starts were, I think 15 milliseconds and nodes were like 200 plus. So just that demonstrates that it's just like you're writing C or something, but it happens to be in JavaScript. For the most part, it translates pretty well. There are some difficulties doing ahead of time stuff, like say I don't support eval because that's dynamic, which you just can't analyze at compile time. But for now, I like haven't really hit that limitation, and like I hope at least in like 2025 that most people aren't using eval.
Yeah, that was going to be one of my follow-on conversation or questions. Is I guess there are just like some really dynamic behavior in JavaScript that is just going to be impossible to represent. Maybe like dynamic imports that have a variable string could be hard to.
Yeah,
I know this is a problem for like bundlers too, right? So if you have a variable in a dynamic import statement.
Yeah, some stuff which seems hard is surprisingly not that bad. Say proxies, for the most part, it's just an object with some special attributes. Then there are some other things which seem really easy, which are surprisingly difficult. Say closures, which like 99% of developers don't have to think about, which is just like, oh, I can share a variable between these two functions, like nested functions, which seems really trivial, but then actually doing that fast is its whole own problem.
Yeah, I was going to ask about this. So I did Recurse Center again last year, and there was like a lot of people working on making their own languages or working on languages. And I was learning about like closure hoisting and specifically in WASM world. And I know you have a WASM compiler. So it'd be fun to talk a little bit more about that. So like, what are the difficulties with closures when you're like compiling it?
Yeah, so closures is probably my most buggiest thing right now, which I'm like in the middle of rewriting at this moment. Just because I guess when I started, I took a very naive approach of, oh, I don't need like full closures. I can just do like local variables and things. But yeah, if you have say like functions nested between each other, like so say like right now, if you try and access a variable in like function foo, and you have an inner function bar, it just won't. It will just throw like a reference error. I don't know what this variable is. So that's one thing I'm working on, which is it's both trivial and also very hard to actually do nicely. Like you could just do, oh, every like variable is in say WASM memory somewhere, which is really easy to do, but then also very slow because it's like a memory access for everything. So yeah, a lot of it is just thinking of like existing approaches, but slightly tweaked to both be nicer for WASM because it has like interesting limitations, which are typically pretty nice.
So we started this conversation off with the supposition that building a ahead of time compiler for JavaScript is an impossible task. Why do people think that? And what was the aha moment that made it possible?
Yeah, so a lot of people say that and still say that, which like I don't really blame them. Because ahead of time is, I have a really strict language like say Rust or C++, and just having it, basically the stricter you have it, the easier doing it is and the faster it is. So like basically my like dream is to just have any JS works, but some stuff might be really slow and some stuff might be really fast. Well, there's no limitation inherently of what you can do. It's just trade-offs of you can do. I know I'm trying to think of something really nasty, but like you can have like as much code as you want, not running the fastest, but it will still actually compile. because even if it's something like, oh, I'm running this node project and it has this dependency which I can't remove, and that dependency is like 100k lines of code, every line of that has to work well if it doesn't have to work that fast. Yeah, I guess I never really had an aha moment. It's just doing it, and I was like expecting to come into a wall, but like the wall wasn't there. And I was just like, oh, this isn't actually impossible. It's just, to a degree, it's just a menial task of I have to implement all of JavaScript again from nothing.
Yeah.
And in its own like strange ahead of time way.
Yeah, it's almost the same problem as like the TypeScript team solved. Like they had to add types to JavaScript, the dynamic language, and like that ended up with people writing a subset of JavaScript. I think the same thing is true here. Is if we got to the end of your development journey here, we'd end up in a place where it's like, oh, this subset of things, this is like the happy path, and you might support those non-happy paths, but they'll be like way de-optimized.
So the nice thing is I support TypeScript natively. There's not even like a transpiler or like any step in between. So like I have an opt-in mode, so like I can use those types as like compiler hints to be like, oh, this will always be an integer. Like just don't bother checking it, like two numbers added together will always be a number. I don't have to be like, oh, are these two strings? I have to like string concat or add a number. It's great because you can just get that for free, but also it's trust you to have sound types.
Yeah.
Which is a trust, which is why it's opt-in. But yeah, like I support parsing TypeScript natively and also have that optionally. And yeah, a lot of it is just, I hope to have it kind of, not linter, but if you use the compiler and you do something obviously known to be bad, it just give you a warning of please rewrite this to be slightly nicer so they can optimize it better. Like that, it's like people aren't aware of their code being like not nice to compile. Like something could look really nice and be horrible.
Yeah, this project reminds me a little bit of, we talked to a guy who'd like built Doom in TypeScript types, like entirely, and it was like he ended up like building like a WASM like interpreter or something in TypeScript types that like he wrote Doom in WASM, and he was just like, yeah, I don't know, it just kept going until I just figured like I would hit some like thing that would say, no, this is impossible, but like that never happened. And I feel like this is the same thing. You're just like, maybe I'd hit a roadblock, but
yeah, because like even compared to other existing compilers, mine is still very dumb. There's so many optimizations I just haven't done because I don't have to care about them yet. And it's still, I think in most benchmarks I've tried twice as fast as QuickJS, which is a really popular like C++ small nice interpreter. And that's I have no fancy, oh, I'm going to do SSA to optimize like, oh, this variable is always this number. I can just delete that, or have like any more fancier compiler techniques.
Yeah, that's cool. So when you're doing compilation, you have like on the homepage, you have two things. So you do compilation to WASM and then compilation to native. Are you planning to retain both of those targets? And can you talk a little bit about the difficulties in supporting both? And are they like, do they have feature parity, or are there some things that you can do in one that you can't do in another, etc.?
Yeah, so WASM is my primary target, and I have native as a secondary, but it's more to the point of like right now I'm focusing on WASM, just because it's like the way the to native kind of workflow works is you compile to WASM, and they have another compiler which is WASM to C, and you just give that to GCC or Clang, or even if you have some weird special compiler for embedded stuff, it should work nicely. So for now, the only kind of pain is maintaining that WASM to C layer, but it's pretty easy. It's just more of a back foot right now, just because I'm just focusing on like getting WASM stuff nicely working, like first and foremost.
Makes sense.
One interesting you made in building this is you wrote all of this in JavaScript itself. Most people wouldn't use that to build something like this. I happened to do a similar thing in college where I built a toy language on top of JavaScript. It was hard. Why did you make that choice, and has that like yielded benefits for you?
Yeah, so like honestly, it was just when starting it, it's the language I know the best, and it's just because like I know some C++, I know some Rust, I know some others, but it's just like I can write this the fastest in JavaScript, so I'm going to use JavaScript. Also, there is like the added like dream goal of one day I can compile with itself. For now, that's still very out of scope.
Yeah, I was going to ask, is Porffor compiled by Porffor? But that would probably like you have to write code like far too much at this point, right?
Sadly, not yet. Hopefully one day. But yeah, a lot of it is just guess what I know the best. I can just crank the code out, not having to care about because like I think Rust is great for like production software, but like this is a like prototype and a research thing first and foremost. Like I'm intentionally not being like, please use this tomorrow. It's like production ready. I'm just like, this is cool, but like you shouldn't use this. You should be excited, but you shouldn't rush to use it. But yeah, I'm getting to a nice stage where like people can try it and please shout at me if you have any bugs. But for now, it's like I expect most things not to work yet, just because it takes a matter of time to just support all of JS.
I'm in a common area, so it might be a little bit louder, but I'll try to stay muted as much as I can.
Yeah. You want to take the Acorn question?
Sure. You're using Acorn for parsing the JavaScript itself that's being compiled, but like most everything else you've done, a lot of it's just written from scratch. So what like motivated the decision to use that?
Yeah, so I guess my main thing is like parsing JS is a solved problem already. Like I couldn't really add anything else to make it better or innovate that. Like Acorn is fast, but like I could definitely write my own parsing and probably be faster because I can just optimize for my use case and not care about anyone else. But yeah, it's nice because right now I have it so like any ES tree, which is like the like compatible format for the like JavaScript abstract syntax tree. Any parser of those like I support right now, so you can even use OXC or yeah. So if I'm compiling, yeah, if I'm taking in TypeScript, I'll use Babel's parser because they have full TypeScript support and also have a compatible syntax tree, which is really nice. So I will change the parser depending on what you're doing, which is really nice to have because Babel supports much more features, even like some proposals which are really early, but also is about twice as slow, just because it's doing more work. It makes sense.
But that's like one of the nice trade-offs of ahead of time is where when you're doing just in time, like parsing and that analysis and loading the JavaScript is much a higher cost. So if you add more to that, like that's bad for UX. But if you add more compile time, like maybe a developer will complain, but you'll still have better UX in the end.
Yeah, I still think like compile time is really important for DX, but in my experience, I'm still worried about it. But in my experience so far, I think the longest compile time I've seen is 2 seconds. And most of that was Clang. So
where do you think Porffor should be used? Like I can see benefits for using it for like your website, but is that the main use case?
that isn't the main use case. Right now I'm like the not sad reality, but like the truth is like I will probably never be faster than V8's fastest just-in-time compiler just because that has I don't know how many millions and hundreds of people working on it because that makes sense. So my goal is just basically instead of so like my like short-term goal is just this is a better interpreter where it's like faster and smaller and everything else. So say you're doing JS to WebAssembly right now, the only way you can do that is you bundle your source code with a interpreter like QuickJS or SpiderMonkey, which is great because it like just works, but also your WASM binaries are like at least 2 megabytes or something, and also it's like very slow because you're interpreting, which isn't that fast to start with, in WASM, which just makes it even worse. So like in my testing, I've seen 50 times smaller sizes and speedups just because it's ahead of time instead of interpreting. And also because WASM is its own format, you're basically interpreting an interpreter. It's not great for performance. But yeah, and then there's so many use cases I never even thought of, which like people approach me with, and I was like, oh, that makes sense. Say serverless AWS Lambda stuff, you just don't have cold starts because it's already compiled. Or say if you're making a game engine, if you want JavaScript or TypeScript as your scripting language, game consoles don't let you ship jits. Game consoles don't let you ship jits for security reasons. So your only choice is an interpreter, which isn't great if you need 5 milliseconds per frame. So if you can just compile all of that ahead of time and take that down to 0.5 milliseconds, that's really nice.
I wonder if there's a use case where you could do both, like use Porffor for some ahead of time for like certain parts of a program and then defer to like V8 for JIT for some other aspects. So if you could apply some heuristics to figure out, oh yeah, this will just benefit from ahead of time.
Yeah, it's definitely, say you have eval or something. My hope is, like, further down the line is I can just fall back to an interpreter for eval, so even that works. But yeah, for now that isn't a priority. Yeah, there's also stuff like, say you're working on like a capture, and like you want that kind of protected and not really easy to reverse engineer. You could compile that to WASM instead of just shipping like minified JS.
Yeah, one other question I had. I know WASM semi-recently, the spec for like version 3 landed, and they've been working on a garbage collector inside of WASM. Are you using that when you compile to WASM, or are you writing your own garbage collection?
So right now, another limitation is I basically just don't have garbage collection right now because in my testing, it's basically just like I will test something and the first limit I reach, I will work on that. And like luckily for now, I've hit other bugs before garbage collection. That's definitely like coming up pretty soon. So my hope is to have like free modes, which is like you can just turn off garbage collection if you're still run for 5 milliseconds and then die. Say Lambda, you probably don't even need garbage collection most of the time. But yeah, then I hope that you can choose between WASM GC and my own GC. Because say you're shipping to embedded, that won't support WASM GC. Well, if you're doing to C, I'll need my own implementation anyway. But then say you're shipping to a browser, you can use WASM GC. Or say you're shipping like a WASM blob to Node on the backend for some reason, you can use WASM GC there.
So you are on some big old committees. Like, congratulations again. You are very young, and that's quite an accomplishment to be on like the technical steering committees of JavaScript itself. So good job there.
Thanks.
Does that work influence your work on Porffor at all? Like, how do you think about browser standards? Like, I saw on the website or some post that you're like, we're not even like implementing any specs, so just see what works.
Yeah, so like for now, I think I have I have 0 web APIs. Well, say it's a timeout or like request response. I just haven't done yet because I haven't gotten to it yet. But it's interesting of like just how web adjacent some things which seem integral to languages. Say set timeout, I think probably the average developer would think is just in the JS spec, even though it isn't. That just most people don't know. Or say like fetch has nothing to do with JS. Actually, it's like a web thing, but it's gone to the it's a nice thing that people can just run that in Node or Dino or Bun or like in the browser, and it just works everywhere. I remember the days of installing Axios or some fetch package, which this is much nicer than. But yeah, like I'll support those inevitably, but like the main thing now is just like the kind of runtimey part isn't there, but it's definitely like a necessary thing.
Yeah, so yeah, I guess that's interesting. Can you make like network calls at all, or are you just like really focused on runtime?
Yeah, right now it's just the engine, the compiler. Yeah. So I have a few bits of IO, like file system things, but that's it. But it's really interesting that it's like I have FFI, for example. So in theory, you can do anything you want by just calling any C library, which is really nice for the short term of if someone wants to do network stuff, they can just use curl. Even though that isn't the greatest developer experience, but it's like a nice short-term solution, accidentally. But yeah, standards is like very important. There are a bunch of things, just being on TC59, just being able to review things, being like, oh, like you could tweak this ever so slightly and it'd be 100 times nicer to ahead of time compile.
Have you provided any of that feedback? Like now that you're the ahead of time compiler guy, are you like
I am the ahead of time compiler guy, I think. Well, to be fair, Meta have Hermes and they're starting to do ahead of time stuff. But I think that use case is still like 99% React Native, which makes sense. But yeah, it is nice to just be able to comment on things, and it's very cool if like your opinion is respected, even if I'm not like I have 0 users I'm shipping to. But like my opinion is still respected nevertheless. So yeah, it's nice to just be able to review things and just talk to people.
I'm sure that you're like going down a non-traditional like execution path, right? And you're thinking about problems that they're not necessarily thinking about, but I'm sure that perspective is valuable because it's like JavaScript itself is like such a widely used language, and it's only going to continue to grow. And like thinking about these like other use case, the performance sensitive use cases in particular, which ahead of time lends itself to, I think is like an important thing to think about as the language develops, I think.
Yeah, there are so many things which like seemingly would have no impact, but are like not ideal to ahead of time compile. Say instead of a function taking 2 arguments, it takes one argument, which is an object. It's like both those arguments in one. Like, you need to allocate the memory for the object and do memory read and writes to that object. But if it was just two arguments, that's just like two things on the heap. So yeah, there are a bunch of things like that where like even one tiny line of code in like user code could make one function run 10 times slower. Sadly, like I had one optimization I did the other day, which is doing like array.prototype.push, because I can take in any number of arguments. It's just a REST array internally, like a REST argument. And before I would allocate a new array every time you called it, which like works per spec and is fine, but then also that's a memory allocation every time in like a really hot path. And I changed that to, it's like an internal function I know I won't reuse this. I can like statically allocate this ahead of time. So like instead of allocating once per call, it allocates once. That's it. And I think it made this benchmark like 10 times faster just with that one change. Because allocating memory is really slow. But like sadly, JS does a lot, which you just can't really help.
So just thinking about this a little bit, I can definitely see like some pretty like niche cases for JavaScript where this would be like absolutely a perfect use case for. So you had mentioned embedded previously, like embedded, like this seems like a great target for embedded. What do you think needs to happen before, or what do you need to finish before like use cases like that, like embedded use cases could really like start being used for something like production grade or whatever?
Yeah, good question. I think there's basically just two bits, which is make 99% of JavaScript being run just work. No, say I have an issue with closures, tweak this line to not use something outside the function. Just have it work reliably. And then also have a runtime thing to just let you do I/O. Be like, anything from write this GPIO pin to do this network call. Just have a nice like runtime layer, which is just, it's pretty easy to do because, so like for embedded, you'd be compiling down to native. So compiling to C, it's pretty nice to just have an abstract-ish interface to just be like, do any of these I/O things, like regardless of the operating system. So yeah, it's something like it isn't hard, it's just time is very limited.
Yeah. For WASM, are you thinking about using like WASM time for like I/O and stuff or something different?
Yeah, this WASI is really interesting. And I have some mixed feelings. It's a generalist thing, so like it can never be perfect for any use. So like I'll probably support it, but like I'm hesitant because since I started this, there's already been like one big version change, and like as far as I know, the interface is completely different. So I'll probably just wait for that to settle first before doing that, or at least get it a bit more stable.
You might be waiting a while.
Yeah, we'll see.
So with WASM, you have some interesting security implications most of the time. Since everything is sandbox, that lends itself to having some nice properties throughout. Are there any extra benefits that Porffor gains from WASM? Does it have any extra security like hurdles within it?
Yeah, so the sandboxing is actually really nice because one of the biggest innovations with just running JavaScript on the server is like Cloudflare workers, for example. They don't have like Docker containers or virtual machines. They just isolate via V8. They just basically trust the V8 sandbox completely and isolate based on that. So like with WASM, you can basically do that, but even lower down, where you don't need a container per user, like a virtual machine per user. You can just have like, here is my WASM process running this WASM. Because WASM is like very well sandboxed, so like you can very easily control like both what the user does and also just having that security. Like WASM is to say like V8 has a bunch of security bugs, like inevitably because it's such a big project. But as far as I know, WASM has much less just because it's less of a surface area. It's like infinitely simpler than JavaScript, especially write for, so there's much less security issues there. So yeah, just having that like layer of protection and also like layer of isolation to be like, I can just run, like say instead of running like 2 virtual machines, which might each take up say 100 megs of RAM, I can run 20 WASM processes, which each take 10.
One of the questions I wanted to ask is a little bit about developer experience. How do you think about debugging Porffor programs? Are you going to try to replicate some of the tools that browsers give, or like?
Yeah, so definitely. Like I've already I think a few months ago I wrote like a basic debugger thing, which is just like a CLI, which just you can like step over JavaScript, like a kind of like very rudimentary Chrome DevTools. You can just do like breakpoints and stuff. So yeah, it's definitely possible. It's just like nothing exists. So yeah, I will also have to make that all, which is fine. It's just yeah, I think for the style will be not easy to develop for, and it just got like better and better over time. So yeah, like stuff like debugging or even just inspecting to just be like, oh, like this JavaScript compiled to this WebAssembly. It's nice because I've had to make some of those tools myself just for like my own DX making it. So it's nice that like I have that kind of dog feeding.
Yeah, I could imagine there's many different tools that you might want to build for this, since it's like almost like a blank slate environment where you can use nothing that's off the shelf, right?
Yeah, like I'm still surprised that this is my rant of the day. There's still no like just oh I want to debug WASM. There's just no way to do that. Just I want to like step by step this WASM. Like Chrome DevTools has it, but then also like I don't want to run in the browser. But there's no just like GDB like thing, for example, for WASM. Because yeah, WASM is still like both. There's so many things to do, like there's so many tools to use it with, and also there's so little at the same time.
Yeah, it's wild. It's been around a while, but it's like the tooling space around it is like moving really slow.
I'd say there's like probably 5 WASM runtimes, but then there's 0 WASM debuggers. So it's very like the tooling is in not the wrong place, but a lot of the tooling is focused on one area, and another area might just be completely just empty. I think we'll just get. It's nice because like I don't have to worry about that because like WASM is used by other people too. I don't even love WASM for the web aspect, just having it as a nice IR layer of just like I want something which can run easily and be translated to other things easily. There's basically nothing else like it. Like the most similar thing is probably like LLVM, and that's like much not nice to use. There's just no other words. So just it's much more just like abrasive, lower level, which makes sense. But just having WASM is like a nice. If I give you WASM, you can probably do what you want using some combination of tools. Or if not, then if I give you C, you can definitely do what you want.
Yeah, probably the portability of WASM there is like the shortfall there. It's like it can be in so many places. So what are you exactly writing a debugger for?
Yeah. It's very, yeah. I think having both WASM and C is like the most portable thing you can possibly do. So that's basically why I targeted those two things.
So on the website, you have a web playground where you can just write some JavaScript and run it. Like, so how does that work? Are you actually, I guess because it's written in JavaScript, you can just load it in the browser?
That's a really nice thing. It's written in JavaScript. I literally, well, it's like the website is the same repo as the project. I think I literally just await import compiler, and then it just works because it's written in JavaScript. And then because it outputs WebAssembly, you can just run that too. And that's like the best. It's like the best and most unrealistic use case of this, where it's just like you can just compile. It's basically acts like a JIT compiler, like accidentally. Yeah, it literally just import like index.html, and it just works. It's like if I would not want to be anyone else doing that with say like GCC or Clang in the browser.
It's so interesting because you could just post some JavaScript to an endpoint and have that return a WASM.
Yeah, you could even like it probably wouldn't be that fast, but you could probably just like Cloudflare work it for like free tier. Here is a WASM blob from your JS source.
It's really interesting.
Yeah, that is one very nice thing of having it run in JS is to like as long as you have Node installed or a browser, you can just run it. Because I've used some compilers before. It's please compile LLVM 14.5.6, and that takes 2 hours to compile, and you're like, oh, okay. But it's also nice because even say I want to make a change, it's just JavaScript. There's no like some weird C+ from 5 years ago. If you touch this line, everything breaks. It's like another, I guess, kind of underrated feature I never really realized until someone told me was just like, it's like I pass just over 60% of the entire like test suite for testing every spec feature, and it's like 25,000 lines of JavaScript and TypeScript. But other engines are like I think even QuickJS is named QuickJS because it's quick and like it's pretty small and it's just like C+. I think that's 80k lines and supports like 85%. So just being able to just having a small thing to work on, it's just so much easier and nicer to maintain. This is V8, which is, I think, well over 1 million lines of C++ and much more.
Yeah, so you just mentioned it there, but the main metric for your development so far has been like completing these test cases and this test 262. So what is that test case thing? Like, where does it exist? And what is like the road been on completing this test suite? Because I think I saw a blog post from you from a year ago where you're like at 35%. How long are we away from 100?
Yeah, so test 262 was named after ECMA 262, which is the actual JS spec. So both are written by TC39, which is the committee who design and make JavaScript. So it's basically just every single thing in the spec, or like almost every single thing, is just tested. Where some test will just be like, here is a for loop, does it run 5 times? On some tests might be like, what is the order of properties in this internal object? And like really more niche stuff. So yeah, it's like anything from that, or anything like even let's say like temporal. I think it's like a solid like 10 to 20% of the entire test suite, just because it's such a big proposal. They like need a big number of tests. So yeah, so right now I'm at like 60%, and yeah, my goal is probably like 90, very long term, because that's where like most big JS engines now are now. I think I will self-promote. I run a website which is just testing every JS engine in existence against it, which I will say is like to a degree as difficult an engineering challenge, just getting every JS engine working nicely in CI. Yeah, so the highest right now is SpiderMonkey, which is at 98%, which is like very good because they have like temporal and everything new basically. So yeah, I hope to be up there eventually. Yeah, I hope like I don't know, ideally like beginning of next year I can stop worrying about the test suite and just be at like a nice stage where I'm like I pass like over 80%, where it's like most things don't work now because someone's using Node APIs and that doesn't work, versus someone's using niche JS feature. I'm just like, I don't support that.
It must be really nice though having that extensive test suite to just like bang against, because how many other languages are you like writing where you have a test for everything?
Yeah, it's like it's like the nicest thing to work on, because like I had my own test suite when I was beginning, and I ended up just deleting it because like even I think almost every commit, it's like every commit I run it in CI, testing against the entire suite, which is like 50,000 test files, even more like assertions. So I just have it so like I get a nice diff every commit or every time I run it testing. It's just 5 new files passed, 10 new files failed. I can just look in each one like, this test is testing this test is testing this. So like some of them are very granular and some of them are very, does temporal exist on the global namespace? Yes or no? And some of them might be like, does this specific regex feature work? Or so many more niche things, which is really nice because, well, it's like a blessing and a curse if there's an infinite to-do list. So like one of the hardest things is just prioritizing. I should add this JS feature next or this JS thing next. But yeah, it's really nice to just be able to test, and also like regression testing. If I'm like, there's a new optimization, I want to make sure I didn't break any JS. 99% of the time, if the test suite changes, I'll know, I broke something, like a random unrelated change. So it's really nice.
So once you get to the end of that road, are there any optimizations you want to make that aren't possible with traditional JS engines?
Yeah, well, I guess a lot of it is just like parity with, say, V8's best JIT compiler. But there's just like, so many more advanced techniques, which I just haven't gone around to. Say SSA, which is like every variable, so internally every variable can be assigned once, where it's like on its own isn't that helpful, but then just being like, this variable is only 52. Then if someone has if this is 52, you can just delete that entire if statement, for example. There are so many things, but if you apply that to types, so this variable is always a string, I can just delete any code checking if it's a number or a big int or anything like that. Yeah, one nice thing you get for free with ahead of time is you basically just get tree shaking for the JS engine and the JS runtime. Say you didn't use big ints, I just ship 0 code in your binary, which is about biggins. So I can just know what you use, basically.
Yeah, I can see that as being really cool. I also think if you get to the point where like IO stuff is externalized, that's like pretty big for if you're building like a durable execution engine or something, you have to like make sure that all you like make all IO deterministic in some way. So it's like seed random and make sure that it like produces the same value on the same run or whatever. And I think there are like some really interesting opportunities to
Yeah, especially with WASM, because WASM is also completely deterministic. So yeah, a bunch of like new things which is just like previously impossible, because it's just like either you can't run V8 or like a big engine for some reason, or like that just doesn't feel use case.
Yeah, I mean, on this topic, so I was working in a startup previously, or started one with one of our former guests, Juan Campa, working on this product called Membrane, which was using QuickJS. And as we were exploring the space, AWS had a QuickJS runtime that came out called the Light Lambda runtime. And there seems to be a lot of people like exploring JavaScript, but like at a smaller, faster scale. Do you think we're just going to see like more use cases like this, like more embedded use cases, more like need for ahead of time? And besides like Hermes, do you think there are going to be more people exploring the space?
Yeah, I think it's definitely like having this definitely like two sides to the coin of both so many people want to use it already, and also I think so many more will appear, and you can just use it and it just works. Well, like I say, like probably every month I hear about a new use case and I'm like, oh, that makes total sense, and I never thought of that before. Yeah, there's definitely, I think, probably more people will explore in the future, but for now, it's just like professionally, Porffor is a gamble. Like, for all I know, I will hit a wall in a week and then give up, which like is 99% unlikely, but who knows? But like, I was just like in the state of my career in life where I was like, I'll do this full time. I'll just do it because like, why not? Yeah, like I say, like first and foremost, it's still just like a research project of like how far can you take ahead of time in JavaScript. So like even if it doesn't end up being like what people use in 5 years, like I hope the teachings from it will be used basically.
What are those teachings, you think? Are there any like lessons that people could take from Porffor and apply to like existing JavaScript engines?
But yeah, I think a lot of it is that like I can't really think of one big thing, but there's just so many niche things where it's just like some things are surprisingly fast, some things are surprisingly slow. One really nice thing is say like strings, because like I'm in a safe environment, I'm in WASM, and like I control the JS engine. I can just write to strings, even though they're unreadable in JavaScript, like internally. Say like I'm concatenating 5 strings in like some internal function. I can just write a string, like a string builder in other languages, instead of having to like, oh, I need to allocate 5 strings, or do a rope string or something. I can just read and write to memory, WASM memory, how I want. So there's just a bunch of things which like typically wouldn't be possible, but you can just do because you can do it internally. Which like existing JS engines do, but like you could do that in userland.js if you really wanted to. Like I have a intrinsic built in, which you can just do inline WebAssembly because I use that internally. You can use that too. Like it's safe. Why not? If you have extremely performance critical code for some reason, you could just write in WebAssembly.
So if you could change JavaScript, the language, in some way to make it easier to do ahead of time, what would you change?
Good question. I'm biased right now because of what I'm doing, but I would say closures because right now I'm doing that and I despise it. But I would say probably longer term, like eval with new function, any dynamic stuff. Probably not even just delete it, but just have it optional to be like you don't have to support these. Because like theoretically, it's required in the spec, and if you don't do it, you're not spec compliant. Which like makes perfect sense. It's just like unfortunate. But yeah, I would just say most dynamic stuff makes sense for some use cases, but should be like extremely heavily discouraged. Like a multitude of reasons, like security, performance, everything. Then yeah, it'd be nice to have almost in a way like a linter, which is just like this JavaScript is slow, this JavaScript is fast. Generally, I think some stuff has existed. Like I think the TypeScript team did some like monomorphization, like checking stuff, which is just if this object is always the same shape, you get 10 times faster like property lookups in V8. It would be really cool to have something like that, like universal, even though every JS engine works differently, so that would never happen, but like in dream. Just more stuff like tooling where it's just like stuff that works between engines and it's just generally useful.
So you mentioned that there were like some edge compute use cases here, which is like interesting to explore. Do you think like the work that you're doing here will be something that we see more in? Is this like somewhere where you actually want to take the project, or is this like specifically for like edge runtime use cases? And then I guess more broadly, when you think about this sort of constrained JavaScript space, be it embedded or performance constrained, how do you just see this space evolving? Will it just be more WASM? Will it be more ahead of time compilers? Or are we just going to get better, smaller V8? You know, what do you think that future looks like?
Yeah, I think there's definitely just like I could just say it's like impossible to predict, but like I think especially with serverless stuff, like I've spoken to multiple companies who are like very interested. So I think definitely it'll be like one of the biggest avenues, especially because a lot of the time in like serverless, like Lambda like stuff, you're already not using that much JS to start with. It's like it's already like smaller, faster things generally anyway. So yeah, because like Amazon already working on their own like JS engine and not or like JS engine and runtime, but that's just like a full JS. It's like just interpreted. There's no JIT or ahead of time stuff going on, which makes sense because that's like question mark millions of investment to get something that works nicely. But yeah, I think the future, like I see many paths, and honestly, I don't know which wins. Like I could see everyone sticking to V8 and just being happy with like how things are, or I could see like V8 adapting somehow, at least for the most part. I might be completely wrong, but like JS engine innovation has stagnated in a way. I think the newest thing we saw was like V8 adding another JIT compiler a few years ago. Versus that, there's no huge like big thing. Like V8's probably adding tiny optimizations every week. There's been no like 2 times performance bump in like the past few years because of some massive innovation. Like I think it'll probably remain that way. Like V8 is it's a monolith. It will probably say the same and be used for like tens of years, which is great. But I think eventually people will be fed up in a way of that like V8 is great and it works, but like V8 is V8. I don't like it'll probably just remain the same-ish, probably slightly faster over years, but like I think V8 is way too like if like in a good way, it's way too stable and like production used to just do radical optimization say ahead of time. But maybe I'm wrong. Like I'm not trying to replace V8 or even QuickJS. I just want to be like I just want like a new option. If this is ahead of time, it works for like it works well for 10% of use cases in total, but in that 10% it works 1,000 times better than every other possible use for like file size or like memory usage or performance or anything in between.
Okay, that wraps it up for our questions. Thanks for coming on, Oliver. You are embarking on a large journey, a very ambitious journey, and it seems like you've made some good progress, and it's very exciting. So thanks for coming on and talking about it.
Thanks.
Yeah, thanks, Oliver. This is a really exciting project, and I'm excited to see where you take it.
We shall see.